Hello everyone. Good morning everybody. Good morning guys. Good morning. Hi Varshika, good morning. Hi Kartika. Hello Abhishek. Hi Chaitanya. Good morning everyone. Good morning. Sorry, good afternoon. Right. Russell, good afternoon. Good afternoon, boys and girls. How's everyone? How's life going on? Good afternoon, everybody. I am great, everyone. How are you guys doing? Good afternoon, everybody. Good afternoon, everyone. Sir, is there any exam on Sunday? If there is, you will be definitely notified about the same. Most probably there should be an exam. Good afternoon, everyone. Good afternoon, boys and girls. Good afternoon, everybody. Thank you, Varshika. Thanks a lot. I'm glad you noticed it. I was waiting somebody would say. You were the first one to say that. Thank you so much. All right. So, shall we begin the class, boys and girls? We have to do an immensely, extremely important topic today. The name of the topic is limiting reagent. Very super duper ultra pro max important topic. Limiting reagent. Everyone is there? Neha, Nakshatra, Tulsi, Pranav. Good afternoon, everyone. Mangal Srinu kahan hai? Where is Mangal Srinu? Meghna, hi. Nagaraj. Mangal Srinu, I can't see today. We need more gravity, sir. Go to Jupiter. You are on the wrong planet. Srinu, where are you? Yes, I am. Mangal Srinu is here. Hello, Srinu. If you need more gravity, you are on the wrong planet, bro. You need to go to Jupiter or some other planet, maybe. Okay, shall we start with the class? Good afternoon, everyone. Sir, my name is Sai Deekshita. Okay. But Mangal Srinu is more. It's got the vibe, right? Deekshita is also a very nice name. Okay, good morning, everyone. So, shall we begin with the class, everyone? Good afternoon, good morning. Deekshita, in fact, is a very nice name. It's a cute name. Okay, boys and girls. Okay. So, let's begin with the class. So, today, I am going to teach you one extremely important topic, and the name of the topic is limiting reagent. Okay. Once again, important topic, and we'll start it from a very basic fundamental level. Okay. See, before I teach you about limiting reagent, once again listen to a story. Suppose there is a factory which is manufacturing bicycles. Okay, there is a factory manufacturing bicycles. So one machine is there which is manufacturing the body of the bicycle. Let's say this is the body of the bicycle. So one machine manufactures the body of the bicycle, and there is another machine which is manufacturing the tires. Okay. And you know that in every body there would be two tires. In every body there would be two tires. Okay. So one machine is there which is manufacturing the body, other machine is manufacturing the tires, and one body will require two tires. That will be your final product, that is the cycle which you will sell in the market, right? Now, in the ideal scenario, what should happen is, in the ideal scenario, the bodies and the tires, should be manufactured in 1:2 ratio. So suppose there are 10 bodies and there are 20 tires. So how many bicycles you will get? How many bicycles you will get? 10 bodies and 20 tires. So what will happen is that both the bodies and the tires will be totally consumed. Okay, 10 bodies, 20 tires, you will be getting 10 cycles. Let's say there are 100 bodies, 200 tires, so you will get 100 cycles. So I hope everybody is able to get the flow what I'm trying to understand over here. Okay, similarly in a chemical reaction, let's say there is a chemical reaction, A plus 2B goes to 4C. A plus 2B goes to 4C. This is a chemical reaction. Okay, now suppose I start this reaction with 1 mole of A. Pay attention everybody. Suppose I start this reaction with 1 mole of A and 2 moles of B. 1 mole of A and 2 mole of B will give me how much of C? 1 mole of A and 2 mole of B will give me how much of C? How much of C will be obtained? Everyone tell me fast. 1 mole of A and 2 mole of B will give me 4 moles of C. 4 moles of C. Okay. Suppose I take 2 moles of A and 4 moles of B. So now I have done what? I have doubled A and I have doubled B. A is also doubled, B is also doubled. So moles of C will also become double. A doubled, B doubled. So moles of C will also become double, and C in this case you are going to get 8 mole. C in this case you are going to get 8 mole. Okay. Suppose if I tell you I have 3 moles of A and I have 6 moles of B. So I have tripled A, I have tripled B. A tripled, B tripled. So C will also become what? C will also become triple. Okay, 12 moles. Now all your answers in this case are absolutely correct. You have given the perfectly correct answer in each case. Perfectly correct answer in each case. Okay. But now what you need to understand is that what is the common theme? What is the common pattern in all these cases? In all these cases, pay attention everyone, the ratio of initial moles of the reactants, is same as the ratio of stoichiometric coefficients. 1:2, 1:2, 1:2, and 1:2. So when the ratio of initial moles is same as the ratio of stoichiometric coefficients, then this represents an ideal situation. This means you have taken the reactants in the same ratio in which they are going to be consumed. Okay, this represents the situation 10 bodies, 20 tires. 100 bodies, 200 tires. 5 bodies, 10 tires. Okay, so this is representing the ideal situation that the reactants have been taken in the same ratio in which they are going to be consumed. So in such a scenario, what happens is that all the reactants are totally consumed. I-POND, finish. All reactants, I-POND. When the ratio of initial mole is same as ratio of stoichiometric coefficient. All reactants are completely consumed. All reactants are completely consumed. So we will note down this point. Okay, chala important point. What is the point? Note, when the Hatmika, I am coming to that. Have patience. Have patience, okay? Note, when the ratio of initial moles is same as the ratio of initial moles is same as the ratio of stoichiometric coefficients. When the ratio of initial moles is same as the ratio of stoichiometric coefficient, then all the reactants are completely, when the ratio of initial moles is same as the ratio of stoichiometric coefficient, then all the reactants are completely consumed. Okay, then all the reactants are completely consumed. Everyone is totally finished. All reactants IPOND finish. Okay, when the ratio of initial mole is same as ratio of stoichiometric coefficient. This is an ideal situation. You have taken them in the same ratio in which they will be consumed. So all of them will be totally consumed. Point number 1. Point number 2, the moles of product can be calculated using moles of any one. Moles of product can be calculated using moles of any one of the reactant. Means over here, first note down this point everybody, then I'll explain. Okay? First note down this point, then I will explain. Please no chatting within yourself yaar. When will you guys learn this? Basic etiquette. I've been teaching you for more than a week now. Still random chat is going on in the chat box. Reddy bhai, I'll explain. Have patience. Nehant Reddy, have patience. Okay. So now the second point which I have written, what does this mean? See, if I ask you, in this case, if I ask you to calculate how much C is produced, all the questions will be answered. Just hang on. How much C will be produced? So you can apply grandpa on A and C, or you can apply grandpa on B and C. In both cases, you will get the same answer. In both cases, you will get the same answer. See, 1 mole of A gives 4 moles of C. So ratio is how much? Ratio is 4 times. Ratio is 4 times. So from 1, 4, 2, 4, 8, 3, 4, 12. So you can apply grandpa on A and C to calculate the answer, or you can apply grandpa on B and C. See, 2 moles of B gives 4 moles of C. 2 moles of B gives 4 moles of C. So that is how much? Double, 2 times. So 2 will give 4. 4 will give 8. Double. 6 ka double, 12. So you will get the same answer. You will get the same answer in both the cases. So whether you apply grandpa on A and C, or you apply grandpa on B and C, both will give you the same answer. Are you able to understand this point or not? And this will happen when everyone. This will happen when this ratio and this ratio are equal. So to calculate the product, you can apply grandpa using any one of the reactants. Using any one of the reactants. Is this okay, everybody? Is this okay, everyone? Yes, this topic will be included in Sunday's exam. Okay? Now, every time the ratio is same, this is not necessary. This is not at all necessary that every time the ratio is same. In a factory, the ideal situation was 1 body and 2 tires. But it is not necessary that every time the ratio is same. Na? There can be a situation when I have 10 bodies and 30 tires. So what will happen in that case? 10 bodies and 30 tires. What will happen? Sir, can we write this as? No, that would mean reverse reaction. Na? So if I have 10 bodies and 30 tires, then 10 bodies will require 20 tires only, na beta? So tires are more than necessary, more than required. Yes. So all the tires will not be consumed. Some tires will be left over. 10 bodies will require 20 tires only. You cannot put extra tire and then it will not be a bicycle, it will become a tricycle. Understood? So if you are selling a bicycle, then one body should have 2 tires. That's it. Yes, so 10 bodies will require 20 tires and you have 30 tires. So tires are more than necessary. So in this case, what will happen, boys and girls? Same reaction, A goes to 2B plus 4C. Okay. And let's say initially I am starting the reaction with 1 mole of A and 3 mole of B. Now, many students, as soon as they hear this, they start saying, no, sir, this is wrong, sir. How can you do this, sir? Cheating, sir. Cheating, sir. Sir, you should take one. Arey, bhai, they are going to be consumed in 1:2 ratio. That is what the equation is telling me. The initial amount which I want to take, the initial amount of A and B which I want to take is totally my choice. Totally my choice. I can take 1 mole of A and 10 crore mole of B. Nobody can stop me from doing that. It is my choice. Okay, my life, my rules kind of a thing. Understood, everyone? So there is no cheating in this, first of all. 1 mole of A and 3 mole of B is perfectly all right. Perfectly all right. There is no harm in that. It's my choice. They are going to be consumed in 1:2 ratio. That is fine. But the initial moles which I have to take, that is totally my choice. I can take anything I want. So now in this case, what will happen is that the ratio of initial moles is 1:3 and ratio of stoichiometric coefficients is 1:2. Ratio of stoichiometric coefficient 1:2. So whenever this happens, when ratio of initial moles and ratio of stoichiometric coefficient are different, then all the reactants are not totally consumed. Then all the reactants are not totally IPND. All will not be consumed total. Okay? So in this case, what will happen is, everybody pay attention. 1 mole of A required how much of B? 1 mole of A required how much of B? 2 moles. 1 mole of A required 2 moles of B. And I have taken how much of B? I have taken 3 moles of B. Okay. So in this case, what will happen is that A will be totally consumed. A will be totally consumed. So the reagent which is consumed first, dekho, you have taken B more than required. 1 mole of A required 2 mole of B. And you have taken 3 mole of B. So you have taken B more than needed, na? So A will be consumed first. And the reagent which is consumed first is known as the limiting reagent. Limiting reagent. Okay. And what about B? What about B, my dear boys and girls? B will be left over, na? B will be left over, yes or no? B will be left over, yes or no, everyone? B will be left over? Yes. So B is known as the excess reagent. B is known as the excess reagent. Limiting reagent, cute name LR. Excess reagent, cute name ER. Now, over here, if I ask you how much product formed, if I ask you how much product formed, so somebody who gives the answer from A, somebody who gives the answer from A, so 1 mole of A is giving 4 moles of C. Grandpa on A and C will give you 4 mole. And suppose if you apply grandpa on B and C, grandpa on B and C, so B2 is giving 4, ratio is double, so 3 will give how much? 6 mole. Are both the answers correct? Are both the answers correct? Which one is correct? If you apply grandpa on A and C, if you calculate C using moles of A, you will get 4 mole. And if you calculate moles of C using moles of B, you will get 6 mole. Which answer is correct? Which answer is correct? 4 mole or 6 mole? 4 mole or 6 mole? 4 mole or 6 mole? Absolutely, yes. So what is the moral of the story? Moral of the story is that if the problem is of limiting reagent, then moles of the product should be calculated using limiting reagent only. You will apply grandpa on limiting reagent and product, not on X, because if you try to remember the logic of grandpa, then in grandpa initially when I was deriving, what had I written over there? Moles of A consumed upon A, moles of B consumed upon B. So why is B giving you a wrong answer? Because this 3 moles of B is not consumed totally. B not aipoindi, B aipoleda. B aipoleda, A aipoindi. Understood? So the reagent which is aipoindi, that is limiting reagent, and product should be calculated using limiting reagent only. If you apply grandpa on B, then there is a problem because B is aipoleda, 3 mole not consumed complete. 3 mole not consumed complete. And product is formed according to moles consumed, not taken. How much is consumed, that is going to decide how much product will be there, not how much you have taken. So you have taken 3 moles of B, but 3 moles of B is not completely finished, not totally consumed. That is why it is giving you a wrong answer. So product should always be calculated using the moles of limiting reagent. Are you able to understand this point or not, everyone? Product should be calculated using the... Can we take any initial ratio? Not at all, Chaitrika. We will see the examples, don't worry. First tell me this point is clear or not, that why 6 mole answer is wrong. Why 6 mole answer is wrong. And why 4 mole is correct. And how we are getting... Dragon, you will understand that. Let me take examples. Don't paint hypothetical situations. You will yourself understand. What will happen if it is 1:1? We will answer that. Nehant Reddy, we will answer that. Bhavani Kotpalli is asking, what is grandpa? Grandpa matlab grandfather, beta. Grandfather is called grandpa, na? Dadaji. Okay, so if you calculate from the moles of A, see, basically the idea is that this A will be totally consumed. So how much product will be formed should be calculated from the moles of the limiting reagent. So 1 mole of A will give 4 moles of C. This answer is correct. If you are calculating from B, so B is not getting consumed totally, na? B is the excess reagent. So 3 moles will give 6 mole when this 3 mole is totally consumed. This 3 mole is not totally consumed. With 1 mole of A, 2 will be consumed, not 3. So product should be calculated always using the moles of limiting reagent. Okay. So now let us write down once more important point. Note number 1. When the ratio of initial mole and stoichiometric coefficient are not same, when the ratio of initial mole and stoichiometric coefficient are not same, then one of the reactant is consumed, and we are only dealing with those cases where there are 2 reactants. More than 2 abhi right now we are not dealing. We are only dealing with 2 reactants, A, B. Then one of the reactants is consumed first and the other is left over. other is left over. When the ratio of initial mole and stoichiometric coefficient are not same, then one of the reactant is consumed first and the other is left over. The reactant consumed first is called LR. The reactant consumed first is called LR. LR stands for limiting reagent. The reactant consumed first is called LR. LR stands for limiting reagent. Number 3, the reactant left over which is remaining. The reactant which is remaining. Okay. The reactant left over is called the excess reagent, that is ER. And fourth and final point, the moles of product must be calculated. Moles of product must be calculated using moles of LR only. Moles of product must be calculated using moles of limiting reagent only. We must only calculate the moles of product using the moles of limiting reagent. So quickly note down these points, then we will discuss some more things. Some of you have asked very good doubts. All those doubts are going to be answered now. You will yourself understand them. Yourself, I will not need to explain. You will yourself understand them. So boys and girls, so far, what are the important things we have discussed? Once again, let's do a quick recap. First point I told you that when the ratio of initial moles and stoichiometric coefficients are equal, ratio of initial moles and stoichiometric coefficient are equal, then all reagents totally consumed. All reagents totally aipoi. And how much product is formed? You can calculate this using moles of any one. Either you can use A or you can use B. You can use moles of any one to calculate the moles of product. Any one. Okay? Point number 1. So is this completely understood, everyone? But when the ratios are different, if the ratio is not equal to this ratio, if this is 1:3 and this is 1:2, or I'm just saying the ratios are different. Okay? When this ratio and this ratio are not equal, then one of the reagent, any one could be there. One of the reagent consumed first, aipoindi, and other reagent aipoleda, left over. So the one which is consumed first is the limiting reagent, and the one which is remaining or left over is the excess reagent. And how much product is formed? That should be calculated using limiting reagent only. Is this understood, everyone? Next, we are going to discuss a very, very important point. Understood, everybody? Dikshita understood? Dragon Break, Hatmika, Mangal Sinu, Rishvita, Snehita. Where is Ajay Verma today? He is not in the class. Meghna, Chimtu, Usha Rani. Okay, very good. Rishvita, well done. Okay, so now our next step is how to Abhi, you will not just put the heading, you will not write down the examples. How to identify limiting reagent. So we can understand that figuring out who is the limiting reagent is ultra pro max important for us. It's very, very important. Okay, so figuring out who is the limiting reagent is very important for us. Now in this case, how did you find out the limiting reagent? You found out the limiting reagent by common sense. Ki sir, 1 mole of A requires 2 moles of B. I have taken 3 moles of B. So I have taken B more than necessary. 1 mole required 2 only, na sir? But I have taken 3. So B I have taken more than what is needed. So B becomes my excess reagent and A becomes my limiting reagent. So you calculated by pure common sense. But this common sense may not be that common if I twist the data a little bit. If I play a little bit with these numbers, then this common sense may not be very, very common. What do I mean by this? Let's have a look. Okay. Suppose a reaction is, Abhi you will not write this down. I will tell you how to find it out. That trick I will tell. 2A plus 3B goes to C, and I am starting with 3 mole of A and 4 mole of B. Who is the limiting reagent? Who is the limiting reagent? A or B? Or none? Sir, both are in excess. Both are in excess, sir. Both are in excess. Or if I write a reaction 2A plus 3B goes to C, and I am starting with 1 mole of A and 2 mole of B. Who is the limiting reagent? In this case, who is the limiting reagent? See, point number 1, my lord. Please pay attention. Objection, please pay attention. If this ratio and this ratio of moles and ratio of stoichiometric coefficient are different, then there is only one limiting reagent and only one excess reagent. So your answer cannot be that both are limiting reagent or there is no limiting reagent. Whenever this ratio and this ratio are not same, there is only one limiting reagent. You cannot say both are limiting reagent. Arey, both limiting reagent ka kya meaning hai yaar? Both limiting reagent means what? Both limiting reagent means both are consumed. So both are consumed, then it is this situation, na? Not limiting reagent. So whenever ratio of initial moles and ratio of stoichiometric coefficients are different, then there is one limiting reagent. So question aata hai, the question arises that how to find that out? Because this is a extremely important step. We cannot leave that on destiny. Ki sir, if God is with me on the day of NEET examination, I will be able to find out the limiting reagent. Because the question will never be that find out the limiting reagent. You will have to do some other things. But identifying the limiting reagent will be the most crucial step of the problem. And if you get that wrong, I can guarantee you that the rest of the problem will be wrong only. If you get it right, still you may go wrong. But if you get limiting reagent wrong, then 100% you are wrong afterwards. So we need to have a proper, scientific, foolproof, guaranteed method of finding out the limiting reagent. We cannot leave that to destiny. Ki sir, upar wale ki marzi hui, if God is with me on that day, then I will be able to identify the limiting reagent. We need to have a proper, foolproof method to identify what is the limiting reagent. I hope you understand why correctly identifying the limiting reagent is so very important for us. Okay? Sir, will you only teach us in the offline classes? Abhi all these questions will be answered, yaar. Abhi let me don't break the flow, yaar. This is some high-end stuff going on. Concentrate. ऐसे ये स्कूल वाली क्लास नहीं, दिस इज ऑफिशियल नीट प्रिपरेशन गोइंग ऑन. Pay attention. Okay. So now listen to me carefully. Question is how to identify LR. How to identify LR. How to identify limiting reagent. Then I will take you back to those examples. Those examples which we have written na where? So how to identify LR. Okay, you have already written the heading. Suppose boys and girls, there is a reaction AA plus BB, and there can be any number of reactants. CC plus DD plus dot. You can take more than one also, doesn't matter. Goes to product. There is a reaction AA plus BB plus CC plus DD plus dot goes to products. Okay, this reaction is occurring. Products. Okay. Now, your step number one is to calculate. See, most of the times you will be given the moles. So if moles are given for all the reactants, very good. If moles are not given, then very quickly you can calculate the moles. Not a big deal. Okay. So after calculating the moles, your step one is calculate moles of A upon A, moles of B upon B, moles of C upon C, dot. Calculate moles upon stoichiometric, moles upon stoichiometric, moles upon stoichiometric for all the reactants. Moles upon stoichiometric for all the reactants. If moles are not given, then calculate moles first. If moles are not given, mass is given or something else is given, then calculate moles first. And then moles upon stoichiometric, moles upon stoichiometric, moles upon stoichiometric for all the reactants. Okay? Once you have done that, you come to step 2. After you have calculated fractions like this for all the reactants, okay, the reactant having minimum value, okay, this fraction, the reactant having minimum value of the above fraction, the reactant having minimum value of the above fraction represents the reactant having minimum value of the above fraction represents the LR. The reactant having minimum value of the above fraction. Once you have calculated these fractions for everything, then that particular reactant for which this number is smallest, means you have taken that reactant in the least amount as per the requirement. You have taken that reactant in the least amount as per the requirement. Okay? So naturally, that reactant becomes your limiting reagent. So this is the step-by-step procedure to identify the limiting reagent. And once note this down, now we will do lots of examples. Quickly note it down, everyone. Example giving. First note it down, na? First complete this. Okay, very good. Quickly complete this, everyone. Write it down. Fast. Done everyone. Mohammad Sheikh completed. Srija, Hatmika, Mamta, Abhi, Rishwita. Done everyone. So let's do a series of problems. Okay, first finish these two problems. Who is the limiting reagent in this case? Okay. Who is 1 minute? Sorry. Okay, yes. Just a minute. So now tell me over here what will you do? Over here what will you do? Everybody pay attention. Moles of A upon A. So this is 3/2. Moles of B upon B. So this is 4/3. Which number is smaller? Boliye bhai, Chepman. 3/2 smaller, 4/3 smaller. 3/2 equal to any 1.5. 4/3 equal to 1.33. Who is the limiting reagent? Mangal Srinu, who is the limiting reagent? B limiting reagent, A excess reagent. B limiting reagent, A excess reagent. Understood by everybody? The reagent for which this fraction is smaller, that is the limiting reagent. Okay, chalo, over here who is the limiting reagent? Over here who is the limiting reagent, everyone? Moles of A upon A. So how much is that? 1/2. Moles of B upon B, 2/3. Moles of A upon A, moles of B upon B. So 1/2, how much? 0.5. 2/3, how much? 0.66. So who is the limiting reagent, everybody? Who is the limiting reagent? A is the limiting reagent. B is the excess reagent. Very simple, very simple. Now guaranteed we can give the answer, na? Understood by everyone? Where is Chimtu? Okay, very good, very good. Understood, boys and girls? Good, very good. Awesome, very good. So next series of problems. See, in these two problems, I was giving you initial moles, right? It may be possible that I am not giving you moles, I am giving you mass. Okay, Srinu bhai? Okay. So it may be possible that instead of giving you moles, I give you mass. So your first step would be to convert it into moles. Okay? Yes, Palla, Srinivas. Moles may not be given confirmly. Mass may be given. So first you will have to convert into moles, and then you will have to do mole of A upon A, mole of B upon B. For example, let's say the reaction is taking place, 2 Mg plus O2 goes to 2 MgO, and I have taken 10 gram of magnesium, 10 gram of oxygen. 10 gram of magnesium, 10 gram of oxygen. Please share your feelings about who is the limiting reagent. Sir, are there any fixed reactions for these questions? Reactions are not fixed. The amounts will be given. The idea is that this mole ratio and this mole ratio should be different. Find out the limiting reagent. Check out everybody. Moles of A upon A. Moles of A upon A. Sorry, first we will calculate moles. First I will calculate moles. I am so sorry. Given mass by molar mass. Molar mass O2 Ne 32. So 10 upon 32. 10 upon 32. Moles of O2 I have calculated first. Then given mass by molar mass. Moles of Mg how much? Molar mass of Mg how much bhai? Given mass by molar mass. Mg molar mass is 24. Now many of you would say, कि sir, why are you not putting for 2 mg? Beta, molar mass means mass of 1 mole, na? Molar mass means mass of 1 mole. तो 1 mole का mass तो 24 ही है ना? 2 is its coefficient. 2 is its coefficient. Understood everyone? So mass of 1 mole is 24 only. So given mass by molar mass, given mass by molar mass. This is moles of Mg, this is moles of O2. Then I will calculate the fraction moles of A upon A. So 10 upon 24 into 2 moles of A upon A. Moles of B upon B. So B is 1 only, na? So this will become 10 by 32 only. So this is 10 by 48. This is 10 by 32. Who is smaller? See, first mass was given. First I calculated the moles. Given mass by molar mass. Given mass by molar mass. And then I am doing moles of A upon A. Moles of B upon B. So I am getting 10 by 48, 10 by 32. Who is smaller? Who is smaller? Who is smaller? Mg is the limiting reagent. O2 is the excess reagent. I hope you know this much math, that the one with the bigger denominator will be the smaller one, na? 10 upon 48 and 10 upon 32. The one which has bigger denominator is the smaller number. If denominator is big, then the fraction is small. Is this understood, everybody? So Mg limiting, O2 excess. Chalo, next question. Are you ready, everyone? Next one. Next problem. Is everybody ready? Tell me fast. Okay, very good. Next one is C plus O2 goes to CO2. C plus O2 goes to CO2. 10 gram. Find LR. 10 gram. Find LR. No, Janvi. Molar masses are given. 10 gram. Find LR. Given mass by molar mass. 10 by 12. Given mass by molar mass. 10 by 12. Given mass by molar mass. 10 by 32. Given mass by molar mass 10 by 12. Given mass by molar mass 10 by 32. Now moles of A upon A. Fraction is same only because this coefficient is 1. So fraction will remain the same. And moles of B upon B. Moles of B upon B. Moles of A upon A. Moles. So these will remain the same. So out of these two, who is smaller? O2. This is smaller, this is bigger. O2, LR, carbon, ER. O2, LR, carbon, ER. Understood, boys and girls? Next problem, everybody. Okay, next problem. 4Al plus 3O2 goes to 2Al2O3. 20 gram, 20 gram. Find limiting. 20 gram, 20 gram, find limiting. Come on, everyone. Twenty gram, find limiting. Well done, boys and girls. Excellent. Very good, very good. Well done, excellent, bhai. That's super performance. English with NKS is asking, Ho, what's your real name? Achha, my real name you are asking. Whose real name? What's your name? What's your real name, as in, does anyone have a pseudonym as well? Just Karan says, Raghu, Ram, can you tell me what does ER in the question mean? ER means excess reagent, beta. When the offline classes will start? Very soon, in May sometime. I don't know the exact date, but sometime in May. Okay. All right. So now what we'll do is that first we will calculate the moles. So given mass by molar mass, aluminium molar mass 27. Here 20 given mass by molar mass, O2 molar mass 32. O2 molar mass 32. Okay. Now moles of A upon A. So 20 upon 27 into 4. Moles of B upon B. So 20 upon 32 into 3. This is equals to 20 upon 108. 27 into 4. And this is 20 upon 96. So who is smaller? This is smaller. And therefore, our answer is aluminium is the limiting reagent and oxygen is the excess reagent. Is this okay, boys and girls? Aluminium is the limiting reagent, oxygen is the excess reagent. Chalo, do one more last question quickly. Last one. Beta, they are the molar masses. Nikhil Sai, they are given in the problem. Don't worry about it. Molar masses are given. Chalo, next problem. S plus O2 goes to SO2. Starting with 5 gram sulfur, 5 gram O2. Who is the limiting reagent? Daya, limiting reagent का पता लगाओ. You see CID? Daya, limiting reagent का पता लगाओ. Daya, find out the limiting reagent. हाँ, CID, ACP, Pradyuman, Dr. Salunke. So who is the limiting reagent? No limiting reagent. Yes. The ratio will be same as the mole ratio. अरे भाई 5 by 32 sulfur. 5 by 32 O2. What is this ratio? 1:1. And what is this ratio? 1:1. So answer is if you say any limiting reagent over here beta, then moe will happen. Okay, so we have to say limiting reagent only when there is a limiting reagent. So don't say both limiting reagent, because when you say limiting reagent, then there must be some excess reagent also. So when both are completely consumed, then answer is no limiting reagent. If you say both limiting reagent, then moe. ठीक है? Sir, did you notice my ID? Deepti Seelam. Have you done something worth noticing? Okay, so that will be all for today, boys and girls. And tomorrow we'll continue from here. Okay. All right. Bye bye. Take care. Have a nice day. I'll see you tomorrow. You are the only teacher who leaves the class on time. Okay. Bye everyone. Bye. Okay. Take care.